So, this Web 2.0 resource has a couple of cool features on the side that we'll first go over. And the first one is show vertical asymptotes. Another is the way that the graph is set up. So right now we have no grids, but we can set it to light, or we can set it to dark, but we're going to keep it on no grid. Under the set window, you can change the size. So we have it from -10 to 10, but we can make this -20 to 20. Okay, so the show trace button over here, if you click it, you can, when you change your variable that's in your function, it will show you what happened. So our original function was right here, and we've moved it so it shows the old ones, so you can compare the different changes that you make to the variables. So that's a kind of a cool function for people too, and you can clear the trace. So this equation is 2x to the -1, and when we do the show vertical asymptotes, this red line comes up because that's the vertical asymptote, so it makes it easy for kids to identify in a graph where a vertical asymptote is. Okay. So if we click on the exponent change, not only does it allow us to change the variables that are in front of the x, the coefficients, but we can also change the exponents, and so you can see the effect that that has on a graph as well. So that's pretty cool.
And you can see that the color of the slider corresponds to the color of the
Right.
constant in the equation.
Right. So here, purple corresponds to the number that's in the front of the x, and they highlight this one green, so the green slider correlates to that. So it's really easy for high schoolers to not get confused on, like, what does this slider change and what does that slider change. You can reset the sliders to go back to your original function, and you can also select limits, so you can't go to crazy extremes or something like that, if you wanted your students to do that.
And this is a really good way for high school students to explore functions without having to graph all those points, which is very tedious.
Right. It's a really easy way to make multiple graphs at once, because you can show the trace and then you can see all those graphs at once. But, and this works for all different kinds of functions, but today we're going to focus on the quadratic because we know how much everyone loves it. So we're going to put in 1 times x to the square. So the reason is, if you don't put in 1 times x squared and you just put in x squared, it's the same thing, but you wouldn't be able to change the coefficient then. So,
and notice too what you had to use for the multiplication sign and for the power sign.
Right. So the multiplication is this shift 8, and the power sign is shift 6. So then you add, and we're going to add 1 shift 8, so times x. And then plus again, and we'll just put in 2 for right now. And we set function. And so then we get the different sliders. The purple one is going to change the 1 times the x squared function or variable. And then the green one is the power function on the x squared. The red one correlates to the 1 in front of the x to the 1 power. And the blue one correlates to the part of the function that doesn't have an x associated with it. So this is a parabola. Right now we have the general formula for a quadratic is ax squared plus bx plus c. So right now we have a being 1, b being 1, and c being 2. So we want to change these things to see how it affects it. So the first thing that we'll do is we'll change the a variable, which is 1 right now, and we're going to slide it over so that it becomes greater than 1. So we'll just make it 5. And as you can see, the quadratic got skinnier. What's a good non-math term for that?
Narrower, skinnier.
Okay, so for you non-math people.
It was a horizontal stretch.
horizontal stretch. Right, but for all the non-math people out there, this is a skinnier function.
Pointing.
Right.
Up.
It's a leaner. It's a smaller distance between the two sides. And we can also, if we wanted to see what happens, we could set it equal to 0. And then we would find that this looks very similar to a linear function, which we should all be familiar with, mx plus b. And that's because now this first part of the function equals 0, and all we have left is 1 times x plus 2, which is a mx plus b, or a linear function. And then the other thing that we can do is we can make this a into a negative number and slide it down here, and then you can see that the parabola is reflected over x equals 2, so it's
Facing down.
right.
Opens down.
Good non-math word is it opens down. So changing it from a positive to a negative causes it to reflect. Okay, so let's set this back to 1 so we can try to play around with these other two. We'll play with the blue, or the b, which is red. So we can make b equal to 0. And so you can see that it just got a little wider.
And it's centered on the
Right,
y-axis.
it's centered on the y-axis. And if we make it larger again, it's not centered, so it makes it easy to see that shift. And if we keep making it bigger and bigger, the center moves down and down, further down. And if we move it to the left so that b becomes negative, then it shifts the other direction. So what's happening is that when we change b, the vertical intercept is changing as well. So we can set that one back to 1, and we'll play around with c, which is blue here, and it's at 2. So first let's just make it 0, because 0 is so much fun. And we can see that the vertical intercept is now at 0, 0. And if we change it to -1, we see that the graph keeps, or more negative, we see the graph keeps moving further and further down. And if we make it positive, it keeps moving further and further up, the vertical intercept does. So we can see that c has some effect on where the vertical intercept is.
And let's go ahead and set both b and c equal to 0.
Okay. Okay, so when b and c are both equal to 0 at the same time, what you have is the vertical intercept at 0, 0, and the center is is focused at 0, 0.
And this point is referred to as the vertex.
Right. This is the vertex of our parabola. And we can just play with these things. So there's no vertical asymptotes on this graph. We can change the grid so we can see it.
We even have the option to print. Had we assigned it as homework,
Yes.
our students could print out their graphs.
Exactly. So this is a really cool tool because it makes it easy for kids to see it. Because not only that, but they can do the show trace. So, okay, so I changed this function. Well, how did that change from the one before? I might not be able to remember that. So the show trace function makes it really easy. Plus, visualizing changes in graphs is pretty difficult, and this allows you to do it pretty quickly and for a lot of different functions and a lot of different changes.
Mm-hmm.
So we really like this Web 2.0 resource, and if I ever teach 9th grade algebra, I definitely think about using it, and I know Tammy is definitely planning on using it.
I'm going to use it in the spring, so.
So, yeah, we think it's worthwhile, and we hope you guys all want to use it too.